Hi everyone, welcome to part 3 of lecture 6. And in this lecture, we will cover the cumulative distribution function of continuous random variables. So far, we have been dealing with discrete and continuous random variables in somewhat separate manners. What I mean, we have used the PMF for the discrete random variable and the PDF for the continuous random variable. So probability mass function and probability distribution function respectively. So it would be desirable to describe all kinds of variables with a single mathematical concept, and this can be done through the cumulative distribution function, or the CDF in short. So beauty of this CDF is what we say we can use it for the discrete random variables and the continuous random variables. So the CDF of a random variable x is denoted by f of x, and provides the probability of x is greater than or equal to some specific value, right? So in this case, the x is less than or equal to x. In particular, we can say that the f of x, the CDF, will give us the probability of x will be less than or equal to some x value, some specific value, will be equal to sum of all the PMF, and if that is the discrete random variables, and in this case, the k will be less than some specific values. And if x is continuous discrete, the continuous random variables, that will be integration of the f of x over the limits between minus infinity to x. Okay, so this is the CDF. So we can simply say that the CDF or f of x accumulates, or that gathers the probability up to some value, and that value is included. So what I mean, if I'm saying the probability of x is less than or equal to 3, what I mean, I will sum up all the probabilities, or I will accumulate all the probabilities until that point. So let's say x can take from 0 to 5, and if I say the probability of x is less than or equal to 3, what I mean, I will accumulate all the probabilities between 0 and 3. So that model, that CDF actually can be used the discrete or the continuous random variable. So we can say that any random variable associated with a given probability model has a CDF. So that's why the x is less than or equal to some particular value is always an event, and therefore has a well-defined probability. We can deal with this kind of probabilities by using the CDF, or the cumulative distribution function. So all kinds of probabilities of any kind of events in the form of x is less than or equal to some particular value can be dealt with the PMF, PDF, or CDF. Okay, and all these things, each of them can be referred as the probability log of random variable x. So the CDF of the random variables contains all necessary information about its log. So if you remember from the discrete random variables, let's say the CDF of it like something like that, right? So that's mean if I know the CDF of the discrete random variables, that's mean I can also know the probability of a particular random variable, because these jumps corresponds to individual probabilities. Okay, and in addition to that one, I can also calculate the probabilities of some inequalities, right? Like that one, like x is less than or equal to 3, 5, anything. So remember that the CDF of any random variable x should satisfy the following properties. the CDF should be greater than or equal to 0 and should be less than or equal to 1. So the range of the CDF will be between 0 and 1. And the limit of f of x when x is reached to minus infinity, that will be 0. And the limit of f of x when x reached the infinity, it will be 1. Okay? So again, the f of x is not non-decreasing function, so that if x is less than or equal to y, then f of x will be less than or equal to f of y. Okay, so if you don't remember these things, please revisit the previous lectures. I will explain all these things in details. And the last property is the f of x is right continuous, such that the limit of f of x when x reaches to the some particular number from the right hand side, that will be equal to f of a for any a value. Okay, so if you remember from the previous lectures, let's say this is the point a, and if I reach to a from left hand side, this value will not be same with this one. I mean, when I get to a here, so these two values, let's say this is x and this is a x star, will not be the same. But if I reach a, if I reach to a from right hand side, these values will be the same. Okay, that's why the f of x is right continuous, but not the left continuous. So let's look at the CDF of the discrete random variables. Let's look at the first example. We have PMF of some x, some random variables, and it will take 1, 2, 3, or 4. So how can I get the CDF from that PMF? Actually, I will just accumulate, or I will just sum the probabilities of that particular random variable, right? What I mean, so this x is in range 1 and 4, right? So anything below 1, the PMF will not be valid for anything below 1, right? So that's why the probability of that one will be 0. And until some point, which is the 1, because it's the smallest value of PMF or random variables, the probability will be same until the point 1, and at that point there will be a jump, and this jump corresponds to probability of x equal to 1, and then it will stay same until the next possible point x can take, which is 2, right? And at point 2, there will be another jump, and that will be the probability of x is equal to 2. And then again, there will be another jump, and this one corresponds to this one corresponds to probability of x is equal to 2, and this line corresponds to the probability of x is less than or equal to 2. In another example, we did the same thing. In this case, that random variables takes 3 different values. And until the first value, the probability will stay same, will not change, and it will be 0 until that point. So the left side of the first possible values, the smallest possible values, will be 0. And exactly at that point, there will be a jump, and this is the probability of first possible values. So, and then we will again stay same until some point, and this point corresponds to the second event, this jumps. So, and then we will get another probability. So this probability, this one, it's something here, corresponds to the probability of x will be less than or equal to that points. Let's say this is the A. So this one is equal to probability of x will be less than or equal to A. Okay, so that was the CDF, and or that was the relationship between the PMF and the CDF. Now let's look at the let's look at the relationship between the PDF and the CDF in the case of continuous random variables. So let's say this is the PDF of a random variable x, and that the range of that random variables between A and B. So, and let's say we have a point C, okay? If I want to calculate the, or in other words, the area of this region actually corresponds to the probability of x will be greater than, will be less than or equal to C, right? So when I calculate the area of these things, that's mean the probability of x, which will be the probability of x will be less than or equal to C. In the CDF, this area actually corresponds to the point here, or that will be corresponds to f of x c. Let's say this is y, so this height will be y, and this y is equal to the area of this region. Okay, this is the CDF. This is the relationship between the CDF and the PMF. So because these probabilities are same, the PMF or PDF is same for all possible values, the CDF linearly increasing, linearly and continuously increasing until some point. And when the value of x reaches to the B, that should be equal to 1, right? Because the area under this PDF, all probabilities, the summation of all probabilities will be equal to 1. So simply you can prove that one, because this area is, this length is 1 minus B minus A, and let's say this is a probability of 1 divided by B minus A. If you multiply these two values, you will get 1. Or vice versa, if you are given this one, and if you know that is the valid PMF, that if that was given to you, you can simplify it this way. So we can also interpret the CDF is your location actually. So let's say this is your speed, the velocity, and by this velocity, where you will reach on that graph, okay? So this is actually how we can interpret the CDF, the relationship between CDF and PDF. So this is another example. So let's say we have a PDF, the f of x, and which is a small f, and until some point the probability will be 0, and then the range of x starts from A to B. Okay. Again, any point here C, let's say the C is here. Any point C, I mean the probability of x will be less than or equal to C, meaning that the area of this region, right? The area of this region, and this region, or let's say this is your velocity, corresponds to some point and in the CDF graph. Okay, and the height of this point, or the value of f of c, let's say, which is y, will correspond to the area of that PDF. Okay, if we sum up, this is the relationship between the CDF and the PDF. Okay, so again, the area in the PDF function corresponds to the probability of x will be less than or equal to some particular point, and this area corresponds to the point on the CDF graph. Okay, and the value of this point, let's say y, is equal to the area of that region, the region on the PDF graph. So if x is discrete with possible values, the PMF and the CDF can be obtained from each other by summing or differencing, right? What I mean, the CDF will be the sum of individual probabilities, right? And if you want to get some particular value from the CDF, let's say the probability of xk, actually, which is equal to the probability of x will be less than or equal to xk. Let's write in a range. Okay, so let's say this is xk and this is an xk minus 1. If you take this part and subtract this one, you will get this one, and this one will be equal to the probability of xk. Okay, so if you know the CDF, you can calculate the particular probability, which corresponds to PMF, or if you know the PMF, you can calculate the CDF. If x is continuous, the PDF and CDF can be obtained from each other by integration or differentiation. So what I mean, the integration of the PDF over the domain between minus infinity to x will give you the CDF, or if you have the CDF, simply the derivative of the CDF will give you the PDF. Okay, so this is the relationship between the CDF and PDF. In summary, in both cases, if you have discrete values or continuous values, you can obtain the PDF or CDF from each other. So this is the end of lecture 6.